In this example, we want to consider two numbers, x and y. We want to show that the absolute value can be used as a distance metric. And generally, we want to extend this to n-dimensional vectors. And we'll see that the argument that we make with real numbers, with a few slight changes, can obviously be made for vectors. Okay, so the first property we need to show is non-negativity. We need to show that the distance between x and y is greater or equal to 0. Well, since the distance between x and y is equal to the size of x minus y, and this absolute value is always greater or equal to 0, the property holds. So this is, of course, satisfied because the absolute value of t is always greater or equal to 0. Next, the distance between x and y equals 0 if and only if x is equal to y. Well, this one's obvious as well, because if x equals 0, if x is equal to y, then the distance between x and x is equal to x minus x, which is 0. If x is not equal to y, then the distance between x and y is equal to x minus y, which is not 0. And because we know that the distance between x and y is greater or equal to 0, showing that those two things are not equal to 0 is good enough. So property 2 is satisfied. Now, if you look at properties 1 and 2, and you think about vectors, certainly component-wise, x minus y would have to be greater or equal to 0. And certainly the distance between two vectors is 0 if the two vectors are the same, because their difference is 0. And if their difference is non-zero, or if they're different vectors, their difference is going to be non-zero, which makes the distance between x and y non-zero. Okay, so both of those hold for real numbers and vectors. Property 3 is symmetry. That the distance between x and y is equal to the distance between y and x. Well, the distance between x and y is equal to the absolute value of x minus y, which we can rewrite as the negative of y minus x. Now, the absolute value of this number, where we're applying a negative sign to it, should be equal to y minus x, where we just get rid of the negative sign and look at the size of the number. But of course, the absolute value of y minus x is the distance between y and x. And so the distance between x and y is equal to the distance between y and x. Again, you can make that exact same argument for n-dimensional vectors. Finally, we want to show that the distance between x and z is less than or equal to the distance between x and y plus the distance between y and z. The distance between x and z is equal to the absolute value of x minus z, which is equal to the absolute value of x minus y plus y minus z. But the triangle inequality for absolute values tells us that this is less than or equal to the absolute value of x minus y plus the absolute value of y minus z, which is equal to the distance between x and y plus the distance between y and z. Again, we can make that exact same argument component-wise for n-dimensional vectors. So, because all four of these properties are satisfied, this is indeed a distance metric.